Hello, my name is Andre. I'm a network support engineer for F5 Networks, and today we're going to be speaking about BIG-IP pools. This is part of our basic troubleshooting sessions. A brief overview of the content. We're going to be speaking about what are pools, what are they used for, so brief introduction to pools, load balancing methods, priority groups, troubleshooting, and some useful resources. So introduction to pools. What are pools? A pool is a logical set of devices that have a service, such as web servers, that you group together to receive and process traffic. So we'll start by looking at the picture below. We have on the left side the clients. They're sending requests to the BIG-IP. The BIG-IP in this scenario has 3 servers which going to load balance the traffic. So if you notice, they have port 80 on this specific scenario. So this is important to understand because the pool members, they need a service. So it's a combination of a layer 3 and layer 4. So you need an IP and a port. A node is what we consider just an IP address. And the pool member has some form of service. And then, depending on availability, we're going to speak about this later, but depending on availability, we will process incoming requests from the clients and we load balancing to available pool members. So if we're doing health checks and, for example, let's say server 1 is not available, we're not going to load balance there, only to server 2 and server 3. There are 3 types of pools that we can configure. One is gateway pools. So this is a simple one. It's just a pool of routers. A clone pool is used, for example, for inspection of traffic when we want to configure the BIG-IP to send traffic to a pool of IDS, for example. In the server pool, it's the most common one, and that's the one we'll be focusing on this session. It's a pool, as we saw in the previous picture, that contains 1 or more servers, nodes with some form of service to process some application traffic. So again, we gonna speak about load balancing as well. This is just a brief introduction. So it's important to understand that because we have multiple servers, we have to somehow choose which ones to send the traffic. So there are multiple algorithms about load balancing methods. On this picture, we have the round robin one, which is the most simple one. We're going to be speaking about it very shortly. It's just a brief introduction to explain that because there are multiple servers, we have to find some form of algorithm to load balance to. So as we said before, a pool usually has some kind of monitoring to it because we need to understand if we have, and taking the example of the previous ones, if we have 3 servers, if we don't monitor anything at all, and if, for example, server 1 is unavailable, if we don't monitor, clients are going to come into the BIG-IP, send some form of request, and we're going to send it to an unavailable pool member. So that's not great because obviously traffic will be disrupted. So we want to make sure that the pool members are healthy and are available to take traffic. So you can perform monitoring. In fact, we advise to perform monitoring. You can have an ICMP, simple layer 3 monitor, or a TCP monitor, for example, or an application layer monitor. Still on the monitors, we're going to perform a whole session. So the first session we did was about virtual servers. This is about pools. And the next one will be about monitors. However, it's important to get just a simple picture of that monitors are also connected with pools. So we're not going to go much deep into monitors themselves, but just a brief overview that monitor is actually necessary. Also about persistence. Persistence is something that we will focus later on later sessions, not today, This is just as well a brief overview that persistence is also connected to pools. How is persistence is a method when you want to send a client to the same pool member again. So for example, let's say that a client comes in, goes to a pool member, and half an hour later, the same client comes back in, and we still want to make sure that this client needs to go to the same pool member. A typical scenario is, for example, if a client is browsing a web server on port 80, clear text, and then decides to make a purchase on the website. So to make a purchase, you will be accessing the secure part of the server. So will very likely be connected to port 443. And because it's a different port and the client is being redirected, when it arrives back to the BIG-IP, we don't know. For us, it's a new client because it's a new port, it's a new connection, and we will load balance to a different pool member. So this is important to understand this concept of persistence, that a client can go to the exact same pool member as before. And we will later on understand why. Why does this fit and why do we need to speak about it? So going on to load balancing methods, there are multiple of them. Some of them are very common, some are very uncommon. Amongst the most common ones, we have the round robin, we have the least connections, and the ratio. We're going to be focused on these three ones today because they are the most common ones. And this is a basic troubleshooting session. Some more information will be provided later on the resources, and also we have our manual pages if you decide that you want further information on the uncommon ones. That is also available. So going into the round robin is the default load balancing method. It will pass each new connection to the next server in line, and it will distribute all the connections evenly across the servers that are in the pool. When to use it, this works well in most configurations. So if the equipment that you have in terms of CPU, memory, bandwidth is fairly the same, then this is a very good method because it's just a very simple one. And in the end of the day, when you have thousands or millions of requests coming in, you're going to see that we are load balancing evenly, which is quite important. So here is an example of a round robin. The clients on the left are making 5 requests. So request number 1 goes to server 1, request number 2 goes to server 2, request number 3 to server 3, and then request number 4 back to server 1, request number 5 back to server 2, and so on and so on. Very simple method. The ratio, it will distribute connections among pool members in a static rotation. In this case, the number of connections that each system receives over time is proportionate to the ratio weighted defined for each pool member or node. So basically this one we're going to see in the next slides. We set up a ratio for each pool members or nodes. When to use, well, this is a static load balancing method, and this is fairly good to use if, for example, you have a brand new server which has a lot more capacity than, for example, if you have an old server. Or let's say that if you have 4 servers in total, 2 of them are brand new and 2 of them are a bit older, you can specify that you want more connections to ones than to the others. So having a more hands-on approach, on this example, we have 2 servers only, server A and server B. On server A, we have a ratio of 2, and on server B, we have a ratio of 1. So this means that server A will get double the connections. So looking at the picture, we see that the clients are sending 6 requests, and we see that server A gets 4 of them, and server B gets only 2 of them. Again, this is quite useful if you have servers with more capacity than others. You can statically define how many connections go to each one of them. So an important notion as well, because we have ratio member and ratio node. Ratio member is about the pool itself. So we are speaking just about this pool. But be aware that, for example, server A, which is on this case 10.1.1.1, can be on multiple pools. So for example, if this server is on 3 pools, a ratio member pertains only to this particular pool. But when you have a ratio node, we'll actually check all the connections that are across all pools. This is important to understand as well. The least connections, the BIG-IP will check member of the pool which has least current connections to it and pass the next request to it. For least connections nodes, the BIG-IP will do the same as above, but across all pools where a node is configured. So it's pretty much the same concept as the ratio node. We will look across all the pools where a particular node is, and we're gonna send to the one that has the least connections. This one works good in environments where servers have similar capacity. Now, onto priority groups. You can categorize pool members into priority groups so that pool members in higher priority groups accept traffic before pool members in lower priority groups. The priority-based member activation feature has 2 configuration settings that you need to adjust. So the first one is the priority group activation. For this setting, you specify the minimum number of members that must remain available in each priority group in order the traffic to remain confined to that group. And then the priority group itself. So when you enable this priority group, you also specify a priority group for each member when you add that member to the pool. So seeing an example here, this configuration has 3 priority groups, as you can see, as priority group 1, priority group 2, and priority group 3. So the connections, when connections come in from the client, they are going to be distributed to the pool members that have priority 3, which are the highest one. And have a look and see that minimum active members it's 2. So what happens is clients are going to come in, we're going to distribute to the members that are in priority 3. But if fewer than 2 are available, so for example, if health checks mark, let's say, the first 2 members from priority group 3 are unavailable, so priority group 3 only has 1 available, then traffic will be directed to the priority 2 members as well. And the same applies because we still have the minimum active members 2. If the priority group 2 also becomes unavailable, then we're going to send to priority group 1. It's important to note that we continuously monitor the priority groups, and whenever a higher priority group once again goes on to a healthy state and has the minimum number of available members, we're going to limit traffic to that same group again. Into troubleshooting. So when troubleshooting pools, there are 2 main questions that we always have to understand. The first one is, the pool members, are they up or they're down? This is quite important because we will only load balance if the pool member is available. So when doing the health checks, it has to be marked available. So we're not going to go too much into this because this is going to be covered in a next session, which is monitors. But it's really important to know that if, for example, we see that the load balancing is uneven, and if we have 3 pool members and only one of them is getting connections, and if, for example, we have round robin, well, something is wrong because round robin will presume that most of the connections go to the same pool. So the connections are balanced evenly. If only one of them is taking connections, well, that's a bit odd. So maybe they're being marked down, and that's a reasonable assumption. So bear in mind, we're not going to go too much detail into this. It's just an overview that always look for the availability. Are they marked as available or not? So in the second one, which we're going to focus more today, is are we respecting the load balancing method used? So an example here, how do we check the statistics then? So how can we determine where the traffic is going to? So via the GUI, we can check on the menu statistics, module statistics, local traffic, and then on the statistics type, we select pools. On this particular case, because you might have hundreds of pools and you might want to look for a specific one. So this pool is called HTTP pool. You can see that I put on the search bar HTTP pool. So it's only showing me this particular pool. So this pool has two members here, 192.168.10.253 and 254, both on port 80. And if you look here, we can see that connections, there's 8 in total for the pool, and there's 4 and 4. So it's evenly balanced. Requests, though, are a bit more to the pool member on IP 253, even though it's the same number of connections. So this is important to understand, because a client might arrive and he might make a couple of different requests, while another client might come in, might only make one request on the same TCP connection. Also, the bits and the packets you can see here. On this particular pool, I'm not going to show, but it's a round robin. It's very straightforward, and we can see that it's load balancing evenly. The connections show it. It's 8 in total, 4 plus 4. So this is a good method to check. Also, via TMSH, we do TMSH show LTM pool, then the pool name and members. And here is the same. We can see as a bit more detail. It's also shows us that the pool member is available, which is the monitor that is monitoring it, the pool name, and the IP addresses. And if we compare with the previous stats, we can see that these stats match. So 4 connections each, and the bytes are the same. So this is the most important part. We're speaking about pools. So how do we troubleshoot? I mean, so this concept here is not speaking about monitors. Again, this is going to go for another one. But how do we troubleshoot if something is wrong on the pool level? So very often, the problem that we hear is the BIG-IP is not load balancing correctly. So what does that mean? It's as I was saying before. For example, if you have 3 pool members and you're using round robin, you're not using persistence, and everything goes to pool member A. So there is something wrong. So it's really important to understand that there are some things that make load balancing be uneven. So not even load balancing. So let's start with the method of load balancing. Certain load balancing methods are designed to distribute requests evenly across pool members. But some other load balancing methods are designed to favor higher performing servers, possibly resulting in uneven traffic distribution across pool members. For example, there are some dynamic load balancing methods that tend to favor high performing servers, and this might result in uneven traffic distribution. The static load balancing methods, as we saw before, the ratio or the round robin, are designed to distribute traffic in a more evenly manner. The second one is persistence. So this one is really important. This is why I mentioned it before. Persistence actually overrides load balancing, because if we have persistence and we see the same client that we saw before, there is no load balancing. We're simply going to return the same client to the same pool member. So as a result, the traffic load across pool members may be uneven, especially if the persistence profile is configured with a high timeout value. So if we configure 6 hours timeout, for example, and the customer is always coming in, it's always going to go to the same pool member. If you have NAT in front of the BIG-IP, this is especially true, because we're always seeing the same IPs, so they're always going to go to the same pool members. Also, again, monitors marking a pool member down constantly. If you only have 2 servers, one of them is always down, traffic is only going to hit one of them. iRules as well. There are some iRules that might persist clients to certain pool members. This is important to note. And UDP traffic. UDP traffic, when multiple UDP datagrams are sent from the same IP address and port to a UDP virtual server, the BIG-IP system by default, it will send all datagrams that arrive within the idle timeout period to the same pool member. So this can result in uneven load balancing. And we will check how to address this later on the resources. Also, OneConnect, this is a bit of a funny one because OneConnect, as we spoke about in the virtual servers, we keep idle connections in the server side. So if a client comes in, makes an HTTP request, and we have some server connectivity on the backend, we're going to send there. We're not going to open a new connection. So there is possible that with OneConnect, you're going to see uneven load balance. Some really useful resources here, I would advise to have a look, especially the one on top, causes of uneven traffic distribution across BIG-IP pool members. It's probably the most important one. Obviously the others are, but that one is very important and I would strongly advise to have a look at. This is our presentation. Hope you enjoyed. Thank you very much.